Hi everyone, I'm Josie Mitchell. I'm going to talk today about a seminar called Diversity of Discovery, using primary literature to learn about discoveries made by scientists from underrepresented and minoritized backgrounds. And I'll probably abbreviate that to URM as I'm speaking today. So since this is all about the stories of different scientists and their discoveries, a little bit about my own story and kind of where I'm coming from. I grew up in the Upper Peninsula of Michigan. I then moved down to the Lower Peninsula of Michigan, where I went to Grand Valley State University, and this is where I did my bachelor's degree. This is where I got involved in undergraduate research, studying X-ray crystallography. I then bounced over Lake Michigan and went to the University of Madison, University of Wisconsin at Madison, in the integrated program in biochemistry. And so this is where I was first introduced to using model organisms in research, and I studied sensory neurons in Drosophila. And this is when I joined and started participating in GSA events and brewmor events. So really excited to be getting to give a talk for one of these events. I then just recently started my position at Kalamazoo College as an assistant professor of chemistry and biochemistry. And I primarily teach biochemistry and also use Drosophila in our research lab. And so the story I'm going to talk a little bit about today is how I developed a seminar during my final year of my PhD, and then how I'm going to be hopefully, applying some of the things from that seminar to what I start teaching here at Kalamazoo College. And so one of the problems that I'm really focused on in my classes is looking at disparity in STEM degree attainment. So when we're thinking about people who are in STEM degrees in undergraduate, who then go on to master's and doctorates, and then eventually are working full-time. This figure shows in academia, but working full-time as a STEM professional. There's a disparity in the number of URM pupils who actually continue on and persist in STEM fields throughout their careers. A lot of this is due to many barriers, okay? So some of those barriers are listed here, and I can share my slides. There's a couple of links throughout the slides for some of these resources. But two of the barriers that I'm focused on in development of some of the classroom materials are thinking about the perceived image of a scientist or an engineer or somebody who's in a STEM field. And one of the ways to overcome this perceived image is by showing people that there are scientists out there like them who are doing amazing things, and starting to develop a student's sense of belonging and identity in science. And so there's a paper, Estrada et al. Back in 2011. This paper looked at scientific self-efficacy and tried to see if this was a predictor of whether or not scientists would persist in STEM. And so the self-efficacy was actually not really as good of a predictor, they found, but instead science identity and internalization of scientific values ended up being a better predictor on whether or not somebody would persist in STEM. So if someone could say, I am a scientist, I agree and value similar values of the scientific community, that would help them integrate into the STEM community and persist throughout various degrees and then as a professional. And so I wanted to kind of take some of this, some of my own interests in integrating this into courses, and I developed a seminar that would highlight discoveries made by diversity of scientists. And so I was going off of kind of two examples in designing my seminar. One was this scientist spotlight homework, and so that's the reference here. So highlighting a different scientist each week is what this spotlight homework was looking at. And then another really awesome resource is this Scientist Spotlights Initiative, which is linked here. You can select different levels of education, college, high school. You can also select specific scientists, and you can look at different standards. So you could look up form and function, you could look up microbiology. So it can really narrow down finding many diverse scientists in STEM. And so I implemented this in a biochemistry capstone lab and seminar. So the lab course was run by Dr. Erica Hsu. This is at the UW-Madison. And I was part of a couple of different weekly seminars. I led my own seminar. Each seminar had 8 students. All the students in this capstone lab seminar course were senior biochemistry majors. And each seminar was usually facilitated by a graduate student, postdoc, oftentimes a faculty as well. And so the lab and lecture component, I'm not going to talk about today. Students would attend lab once a week for 3.5 hours. They would do asynchronous lecture material. But the seminar part was once a week. We met every Monday. And the way I formatted my seminar was before the seminar, the presenter would read and analyze their article. They'd prepare a 25-minute presentation. And I put an emphasis on, as you're preparing this presentation for your seminar, think about and research the background of your scientist and spend some time at the beginning of your seminar talking about the history of that scientist. We talked about some scientists as well as scientists from the past. The presenter would meet with me, we'd fine tune their presentation. They'd also choose 3 questions that were written by their classmates in a pre-class assignment, so they could discuss those at the end of their presentation. And then all students in the seminar would read and critically analyze the article. And I would do some guided reading assignment at the beginning to help them read through the article and digest it. Because one challenge that I've found in integrating primary literature into the classroom is kind of, where do you start? It's a different language to read and to interpret. And so I'd have guided questions that would take them through this. During the seminar, the presenter would give their talk. They would discuss the author's backgrounds, trajectories, and then they'd also highlight major findings of the paper. So we would work through each figure in a journal club style format. All the other students would listen and engage and then ask questions for about 20 minutes at the end. And these were really fun. They became discussions and the students really warmed up to each other after about the first week. And I really think it helped having that story of who are these authors to get people warmed up to, like, these are humans doing this science, and we could do it too someday. After the seminar, the presenter would answer questions, and then I chose to do a minute paper for the students to give the presenter feedback and ask additional questions and reflect on some of the work they had learned about. So this is kind of the format of how the seminar was laid out. Some of the learning goals I had for students were learning how to critically read, evaluate, and discuss peer-reviewed journal articles, as well as recognize the contributions made by scientists from URM backgrounds. And then lastly, I wanted them to value the importance of having diverse voices for innovation and progress in scientific research. So these were laid out in the syllabus. I also did a pre-class survey before we even started the semester and asked the students what some of their goals were. Some students said that they wanted to gain a deeper understanding and further appreciate the work of minority scientists. Some students wanted to learn about the stories and achievements of people in STEM that are historically underrepresented. And another student was excited to explore discoveries made by people in underrepresented communities. This person happened to grow up in close relationships with Indigenous communities. So the students in the capstone course could pick their seminars. And so there were about 8 different seminars they could choose from. And so the students who chose my seminar were clearly interested in starting to learn about the scientists doing the work. Different seminars had different topics to them. So how I went about choosing the research articles for the seminar was, first I considered the students in my classroom, and I looked at that pre-class survey I had them fill out. And I chose articles by scientists with diverse as well as shared backgrounds with my students in the course. Primary literature was chosen based on representing various different scientists from both modern and historical concepts. And I also wanted to point out that I got many of my ideas from science artists who did science highlights or scientist highlights on their social media. So for example, at Nina Draws Scientists, this is an Instagram account that highlights various scientists, looks at different discoveries made by these scientists and highlights them week to week. JKX Comics is another one. So these are good kind of places to start when thinking about choosing some of these papers. And I think I'm seeing some annotation on the screen. I don't know if I did that, but we'll just keep going. Okay, so the different papers that we ended up moving forward with are going to be listed here. So one of those, as we heard about in the previous talk, is the Martin Janek 2012 CRISPR paper. We also highlighted the Corona paper looking at gene synthesis, a paper by Judy Simcox, She works at UW-Madison. Gertrude B. Elian, Tracy Johnson, as well as a more traditional historic paper looking at the Michaelis-Menten equation and derivation of that. We looked at a more modern paper by Kizzmekia-Corbett and many other authors in the development of the mRNA vaccine for COVID-19. And then lastly, Barbara McClintock's classic paper looking at transposable elements and looking at this in corn. So these are the papers that we ended up moving forward with, and students were able to pick which paper they wanted to do for their week. Before the class, students would do a pre-class guided reading assignment. So here's an example of one of those. So I would list a couple different questions. Each week it was a little different depending on the paper and the length of the paper too, how many questions I'd include. But the first question was always spend some time researching your scientists, the authors on your paper, okay? Reflect on what you learn about them and then share that with the class. Second, we really worked on practicing finding the gap of knowledge in a paper. And so it's easy to get lost in all the details of a paper, but I really focused on what's the gap of knowledge that this piece of literature was trying to fill. Sometimes I would add in a short article in addition to the main article just to kind of look at. So this is another 3-page paper connected to an author at UW-Madison. So connecting it to somebody that these students actually knew. So again, seeing others doing science, and these people are human too. You can do it too. So then after this, the student would read the paper, they'd then have to write at least 2 questions. And several of these questions will be chosen and discussed by the presenter. And so here's an example from the paper by Kizzmekia-Corbett. These are student slides here. So Kizzmekia-Corbett highlighting some of her background, kind of where she came from, her education, and then highlighting figures. So each slide we would talk through the figure, and we would do it dynamically where we'd pause and discuss aspects of the figure together. So a few different pieces of feedback in general. All the students were very pleased and enjoyed the seminar. The seminar met their expectations. And then in response to the question, how confident do you feel in recognizing contributions made by scientists from URM backgrounds and value the importance of diversity for innovation and progress in scientific research? The majority of the class is very confident, and one person was not confident. I really want to follow up with that person and see what we can do better. But overall, student reflections, some of the things that people really liked were the focuses on the scientists and talking about some of these URM scientists and their discoveries. I think this kind of took a little bit of the emphasis off of the denseness of papers, but some students still commented the papers felt too dense. And we talked about this too, where it's your first time reading through scientific literature. It's practice. You're not going to get it right away. But many students wanted some more background knowledge before their papers. So looking forward, I'm thinking about ways we can do a little more background before diving into some of the jargon of a paper. So some takeaways, and to kind of wrap up, overall students really did feel more confident in recognizing contributions made by URM background scientists. In future lecture and lab courses, I'm planning to include a weekly journal club component and integrate some of this seminar into that. So highlighting the scientists themselves in addition to the work. And then I also want to guide the students as they choose their own papers. So instead of me providing that list at the beginning where students are picking from it, introducing Zotero, getting them used to reference managing, and also researching some of these scientists and picking their own papers. And so I'll wrap up and say thank you to the UW-Madison Department of Biochemistry, Dr. Erica Hsu, who was the course coordinator for this capstone, students in my seminar back in 2021, and then all of my support here at Kalamazoo College and all the awesome students that I get to work with now. Thank you.
Wonderful. Any questions? Seeing lots of claps. Katie.
Hey, yeah, I was wondering, great talk, by the way. I'm really excited about the work. I was wondering if you could go back to that first week. figure where you showed the different papers that you covered. I think it was like week 1 through 4.
Sure. Here we go. So week 1, 2, and 3 are here, and then, yep.
Okay, great. Thank you. I was just, I think I might have missed that one. I was really excited to see the diversity of scientists that you chose. And I would love to contact you if you don't mind sharing your contact information and chat more about this. I think this is a very important topic that we're helping students. You're doing multiple things here. You're helping them figure out how to analyze the scientific literature or even just read it, for crying out loud. I mean, that's a skill in and of itself. And then also that you're introducing the diversity component. I really appreciate this. Thank you.
Thanks so much, Katie.
Wonderful. I also want to say congrats, and I want to do one small question as well. Did you have a way, this is my issue, did you have a way to steer students away from reviews and onto actual research articles?
Yeah, that's a good question. I run into that in some of my seminar courses currently where I'm teaching. For this course, since I chose the articles, I had a list and the students would choose from them. So they weren't really like allowed to choose a review. It had to have some figures in it. Moving forward, though, I think when I'm helping students pick figures, pick papers, it'll be a good discussion on using reviews to get started with something, but then finding some of those references with data and figures so we can actually talk about it in more of a journal club style format. And that's good practice too, kind of tracking back from a review to find some of that initial data that led to the one sentence in the review.
Wonderful. I'm trying to distill down some of the questions in this brief time. Do you have a guide for how to read papers? Do you provide them a guide, or do you do it hands-on?
So since we only get, like, for this particular course, an hour together, we did a lot of stuff pre-class, and so that's where I had the guided reading questions. I will probably bulk that out more and walk through each section of the paper a little bit better, so that it can kind of guide students through the reading. I think that's where students struggled the most, was with the density